All right, we are in 2.6 again, section 2.6. It is on page 143 in your textbook. It's number 18. And taking a look at this, we were asked to find the equation of a tangent line for the graph y equals g of x. So in other words, we don't know what the actual function's graph looks like, but we do know the point we're supposed to find it at, and that point happens to be x equals 5. We know that the value of the function at x equals 5 is negative 3, and we know the slope of the function at x equals 5 is 4. That's what all these things mean. So we know y equals mx plus b, or if we use my method, it's y minus y equals m times x minus x. All right, I'm going to use this because I was given all the information I need. If we come back to this guy right here, this is actually a point. It is the point 5, negative 3. And we know that the curve and the tangent line have that point in common because that is where they're tangent to each other. It's the only point that they have in common. And then if we go to this part right here, g prime we know is a slope function. So I know that this is going to be, the slope of this equation is going to be 4. So if I put it all together, it's going to be y minus the y, and here's my y value, negative 3, and then equals slope times x minus the x, and my x value is 5. So obviously we have y plus 3 equals 4 times x minus 5. Now if you want that in this form right here, in the slope-intercept form, we simply need to distribute the 4, so we get 4x minus 20, and then subtract the 3 from both sides, and finish it up with y equals 4x minus 23. And that's it. You were already given all the information you needed, you just had to put it into an equation. All right, I'm going to go ahead and do number 19 next here, so we'll go to the next slide. All right, on number 19, it's a little backwards from number 18 because we're actually given the slope, or sorry, we're given the equation of the tangent line. So here's the actual equation of the tangent line. Now again, I don't know what the original function looked like, but I know when a equals 2 or x equals 2, I know that this equation right here will get me the slope, or that would be the equation, sorry, for the tangent line. So taking a look at that, I can go, okay, what is the slope? This is in the form of y equals mx plus b. The slope is the m. So I actually already know the slope, and we know that f prime finds the slope. So because I already know the slope just from looking at that equation, I know f prime of 2 has to equal 4, because that's the slope of the tangent line. And that's exactly what f prime means. All right, so then I'm supposed to find f2 as well. Well, f2, if these two have the same point in common, I mean a tangent line intersects the curve in exactly one point. So I know that they share a point. They share the point when they touch when x or a equals 2. So all I have to do is figure out what would be the corresponding y value in this function for 2, and it's got to be the same for the original curve because it's the point they share. So if I plug 2 into that, I get 4 times 2 minus 5, which is positive 3. So I know that f of 2 equals positive 3 because the tangent line at 2 has a y value. Well, then the function itself also has to have a y value of 3 because it's the point that they share. So in other words, the curve has the point 2, 3, and the tangent line has the point 2, 3.